solutions are homogeneous mixture of two or more components. We know that a solution is made up of, or the components which make up the solution are solute and solvent. Now what is gaseous solutions? The solvent will be gas and the solute can be either solid, liquid or gas. Mass by volume percentage of a solution is defined as mass of solute dissolved in 100 ml of solution. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry, Vidhyaashram School of Excellence, Mysore. So today we are beginning with the first chapter of your syllabus, that is solutions. So before beginning, I hope that you maintain the excitement and concentration that you have in the beginning of the year till the end of this year. So without further wasting time, let us begin with the chapter. Yes, so we are beginning with the first chapter of the syllabus, that is solutions. So regarding solutions, you already have a quite idea about it from class 9 itself. Yes, you have studied what exactly are solutions and the different types of solutions. Yes, and what are solutions made of? All this you have already studied in class 9. And yes, based on that basics you have studied in class 9. Yes, on that further we will be studying in this chapter in this year, right? So in today's session, what and all we are going to study is, yes, the basic introduction about solutions we will be discussing, and then about solute and solvent, and then we will be discussing about the different types of solutions, that is solid solutions, liquid solutions and gaseous solutions. In detail we will be discussing, and then we will move on to the next part, that is concentration of solutions, in which you have to study about different methods or different terms with which we can express the concentration of terms, concentration of solutions, and out of which the three we will be studying. These three we will be discussing in this session, that is mass percentage, volume percentage and mass by volume percentage. Yes, so let us begin with the topic, that is solutions. Yes, so what exactly are solutions? Let us begin with the definition itself. Yes, so solutions are homogeneous mixture of two or more components. So what it is homogeneous mixture of two or more components. So you know what is a homogeneous mixture? Yes, homogeneous mixtures are mixtures in which the composition is uniform, right? So as you can see here, yes, if I take a glass of water, yes, and I am adding 1 tablespoon of sugar into it. Yes, and I am mixing it thoroughly. What do I obtain? I obtain sugar solution, right? So in this sugar solution, are you able to observe any different layers? Or after mixing the sugar into the water, if you are observing the glass, are you able to see any different layers there? No, right? Yes, are you able to say that yes, in this part sugar is present, in this part water is present? No, right? No different layers or no different sections are present there. Now it is an example of a homogeneous mixture, right? Because it is uniformly distributed throughout the mixture, right? So such mixtures are called as homogeneous mixtures. Yes, so homogeneous mixtures having two or more components are called as solutions. Right, so what is a heterogeneous mixture then? Yes, as you can see here, yes, an example of muddy water, right? If we mix mud and water together, we get muddy water, right? So in this case, as you can see, it is distributed over the water, right? So if I am keeping this glass still for a little bit of time, what happens? This mud will get settled down on the bottom of the glass, right? Yes, so then what will you be able to observe? Two different layers, right? Water will be on the top part and yes, the mud will be on the bottom part, right? You will be able to observe different layers, right? So such mixtures are called as heterogeneous mixture and they do not form the solutions. So I hope the definition is clear. So solutions are homogeneous mixture of two or more components. Right. So what are these two or more components which make up the solution? Yes, they are called as solute and solvent. Right? We know that a solution is made up of, or the components which make up the solution are solute and solvent. Right? So in this session or in this chapter, we will be only discussing about binary solutions. Right? Only binary solutions. That is a solution that contains only two components. Okay? We will be only discussing on such solutions in which there are only two components. Right? There will be one solute and one solvent. Yes, only two components. Right? So, coming back to solute and solvent. So, what is solute? The solute is the substance which is present in smaller quantity in the solution. Right? And what is solvent? Solvent is a substance which is present in larger quantity in the solution. Right? So, the first slide we saw that, yes, when we are preparing sugar solution, what do? We add 1 spoon of sugar to the glass of water. So, in that, can you say which one will be the solute and which one will be the solvent? Yes, the sugar, we added only 1 spoon of it. Right? We added only 1 spoon. So, compared to the quantity of water, right, as you can see, the sugar is only present in 1 tablespoon. So, the quantity of sugar present here is very less. Yes, so that will be the solute and it is added on to the water which is present in more quantity. Right? So, that will be the solvent. So, I hope it is clear what is solute and solvent. Right? Okay. So, now we are going to study about the different types of solution. Yes, so when I say solution, suddenly what does come to your mind? It will be generally some liquid, right? The sugar solution, salt solution, lemonade, all these will be solutions. They are generally in liquid phase. So my question is, are there solid solutions and gaseous solutions, or there are only liquid solutions? Yes, so what you have to understand? Yes, there are solid solutions, liquid solutions as well as gaseous solutions present. So, based on what we can classify them into solid, liquid and gaseous solution. So, we just studied about solute and solvent, right? So, based on the state of the solvent, yes, we can classify them into solid, liquid or gaseous solution. That means, if my solvent is present in solid state, yes, the solution that I obtain will be solid solution. If the solvent is solid, yes, the solute can be solid, liquid or gas, right? So, all of that will come under solid solutions. If the solvent is liquid, yes, the liquid solutions are obtained, and in this case, yes, the same way the solute can be liquid, gas or solid, and in the same way when the solvent is gas, yes, gaseous solutions are obtained. And there also the solute can be solid, liquid or gas. So, what you have to remember? Yes, the solvent as it is present in greater quantity. Yes, this is the factor or this is the substance with which we can determine which solution it is or which type of solution it is. Right. So, let's discuss each one of it. So, we are beginning with the solid solution. So, as said, the solution in which the solvent is solid and the solute can be solid, liquid or gas are called as solid solutions. Right. So, now under solid solution itself, there are 3 categories, that is based on the solute which is present. If the solute is solid and the solvent is also solid, we get solid in solid solution. We write it like that, that is solid in solid solution. That means the solute is solid and the solvent is solid. An example for it is alloys, right? So, you know what is alloys? It is a mixture of metals, right? Yes, when metals are mixed in a homogeneous composition, we get alloys. Yes, the bronze, brass, yes, the coins are made of. Yes, so the bronze and brass, all of that are mixtures of various metals, right? So, that is an example of solid in solid solution. Now, if the solute is a liquid, we obtain liquid in solid solution. That is, the solute is liquid, but the solvent is still solid, right? Liquid in solid solution. An example for it is amalgam of mercury with sodium. Yes, as you can see, the amalgam of mercury with the sodium. Yes, that is an example for that. Moving on to the third one, that is gas in solid. That is, the solute is a gas and the solvent will be again solid. Yes, so in that case, the example for it is solution of hydrogen in palladium. Right? So, in this case, yes, the palladium is solid and the hydrogen, as you know, it is gas. right? So that is an example of gas in solid solution. So this is about solid solution. Yes, I hope it is clear. And the three types of solid solutions are solid in solid, liquid in solid, and gas in solid solutions. Clear? Now moving on to the next type, that is liquid solutions, right? So the solution in which the solvent will be liquid, yes, and the solute can be solid, liquid or gas are called as liquid solutions, right? So the first type is solid in liquid solution. That is, the solute is solid and the solvent is liquid. So what example can you say in this case? Yes, glucose dissolved in water, sugar dissolved in water, salt dissolved in water. All of these are example of solid in liquid solutions, right? Yes, the solute that I am adding is in solid state, right? And yes, the solvent to which I am adding it is in liquid state, right? Yes, now liquid in liquid solutions, right? Now both the solute and solvent are liquids, right? So an example for it is ethanol dissolved in water. So both of these are present in liquid states, right? So such solutions are called as liquid in liquid solutions. Now the third one is gas in liquid solution. Yes, gas is the solute and liquid is the solvent. An example for it is oxygen dissolved in water. Now, where is this important? Oxygen dissolved in water, right? How do aquatic animals or aquatic species survive? Yes, because of the oxygen which is dissolved in the water, right? They don't come outside and breathe from the atmosphere, right? So, the oxygen is present inside the water, which is dissolved in the water. The aquatic animals do use that, right? So, the oxygen which is dissolved in water is important in that case, right? So, gas in liquid, oxygen dissolved in water is an example for gas and liquid solution. So, I hope this is also clear. So, now moving on to the next one, that is gaseous solutions. Now, what is gaseous solutions? The solvent will be gas and the solute can be either solid, liquid or gas, right? So, the first type is solid in gas solution. That is, the solute is solid here. Yes, camphor in nitrogen gas can be an example. Yes, so have you seen the sublimation process? Yes, you have already studied what is sublimation process, right? When we heat camphor, what happens? Yes, you can see the evolution of gas from it. From solid state, directly it is getting converted into gaseous state, right? So, yes, that is an example for that. Now, next one is liquid in gas solution, right? Chloroform mixed with nitrogen gas. Now, chloroform is in liquid state and yes, the nitrogen is present in gaseous state. So, that is an example, right? And the last one is gas in gas, right? An example for that is mixture of oxygen and nitrogen gas, or in general you can say air, right? It is a mixture of various gases, right? Which is also an example of solution, right? So, gas in gas solution. So, I hope the different types of solutions are clear for you. So, let's summarize it. Yes, what did we understand? There are gaseous solutions, liquid solutions and solid solutions, right? So, as you can see in the gaseous solutions, the solvent will be always gas. The solute can be gas, liquid or solid. So, what you have to do is, when you are studying each of these solutions, different types of solutions, you need to be able to write the solute and solvent corresponding to it, and at least one example you should be able to illustrate. Yes, I hope it is clear. Yes, so there are gaseous solutions, then liquid solutions in which the solvent will be liquid and the solute can be gas, liquid or solid, and in the same way solid solutions, the solvent will be always the solid, but the solute can either be gas, liquid or solid, and we even discussed about the different examples for each of it. So, I hope the different types of solutions are clear for you. Now, moving on to the next topic, that is expressing concentration of solutions. So, before understanding how we can express the concentration of solutions, we need to be knowing what exactly is the concentration of solution, right? So, the concentration of solution is the amount of solute which is present in a given quantity of solvent of the solution. So, in a given quantity of solvent, right, how much amount of solute is present, that is basically the concentration of the solution, right? So, if more amount of solute is present in the same quantity of solvent, that means if I am adding, let's take the example of sugar solution itself, I added 1 tablespoon of sugar. Right, now I am adding 3 tablespoons of sugar. Which one will be having more concentration? When I am adding 3 tablespoons of sugar, right? Yes, so I hope you understood what is concentration of solution, right? So, now what we are going to study is different ways in which we can express the concentration of solutions. Now, why it is necessary? Let's understand by taking this example of copper sulfate solution, right? So, in the first case, I took few crystals of copper sulfate and I mixed with water. I got this color. Right. Now, I am adding a little more copper sulfate and I obtained this color. Now, I added even more amount of copper sulfate, and in all these cases, the amount of water is just the same, right? Yes. And I am adding more amount of copper sulfate. I obtained this dark blue color. So, from this, you can see from this light blue, we are finally getting this dark blue color. So, if I am asking you just by seeing the color, can you tell me which one will be having more concentration? Yes, you would say this one, right? Which concentration will be more? Because the color is the brightest there. That means more amount of copper sulfate is there, right? So basically you can say that. But in all cases, you won't be able to see the color difference, or you won't be able to identify a smell or a taste difference or anything like that. So in all chemical reactions, this can't be possible, right? So there must be a method by which we can express the concentration of solutions, right? So we are going to discuss about the various methods to express the concentration of solutions. So we will be discussing about mass percentage, volume percentage, mass by volume percentage, parts per million, mole fraction, molarity and molality. Yes, these are the different concentration terms with which we can represent the concentration of solutions. So, in this session, we will be discussing on the first four, right? So, beginning with the first one, yes, mass percentage. Yes, as you can see in the name itself, it is something related to mass, right? Yes. So, what is mass percentage? Mass percentage of solution is defined as the mass of the solute dissolved in 100 gram of the solution. It is the mass of the solute dissolved in 100 gram of the solution. And how you can obtain it? By the equation. Yes, mass percentage will be equal to mass of the component in the solution. Yes, the mass percentage of which component you have to assess that mass of the component in the numerator divided by the total mass of the solution multiplied by 100 will give the mass percentage of that component. Clear? Right. Now, if a solution is described by 10% glucose in water by mass, let's say if it is given that, yes, a solution is present which is having 10% glucose in water. What does that actually mean is, yes, in this solution, there is 10 gram of glucose. Okay, 10 gram of glucose, yes, it is 10%, right? So that means 10 gram of glucose is dissolved in 90 gram of water. That is what it means. Yes, 10 gram of glucose which is dissolved in 90 gram of water, which gives a total mass of the solution as 100 grams, right? Yes, we know that mass of solute plus mass of solvent will be equal to mass of solution, right? We know that. Yes, a solution is made up of solute and solvent. So, the mass of solute plus mass of solvent will give you the mass of solution. So, 10% glucose in water means 10 gram of glucose is dissolved in 90 gram of water, which gives a total of 100 gram of solution. Clear? That is 10 gram of glucose is present in 100 gram of solution. You can also say it like that. Yes, and mass percentage. Yes, it is commonly used in industrial chemical application. Yes, it is used for commercial bleaching. Generally, this concentration term is used for industrial applications. Clear? Now, let's do a numerical based on it. Yes, you have to calculate. The 10 gram of sucrose is dissolved in 100 gram of water. Now, calculate the mass percentage. It is very simple, right? How do you calculate mass percentage? Mass percentage is equal to mass of the component. Yes, that is sucrose, right? So, the mass of the component is given, that is 10 gram. Divided by mass of the solution. Mass of the solution is also given here. Yes, 10 gram of sucrose is dissolved in 100 gram of water. Yes, mass of solution is also given here. Yes, now what you have to do? Mass percentage you have to calculate, right? That is mass of component by mass of total solution multiplied by 100, right? So that gives 10 percentage, right? So that is the mass percentage. Clear? Now moving on to the next concentration term, that is volume by volume percentage, right? Volume by volume percentage, or you can just also say it as volume percentage, which is represented by V/B. That means volume by volume percentage. Clear? Now volume percentage is defined as the volume of the solute dissolved in 100 ml of the solution. Yes, it is similar to mass percentage, but now we are representing it in terms of volume. So what is volume percentage? How you can calculate it? It is volume of the component in the solution by total volume of the solution multiplied by 100. Clear? So if it is given that, yes, for an example, 10% ethanol solution in water. So now what does that mean? 10% ethanol solution in water means, yes, 10 ml of ethanol is dissolved in, yes, it's dissolved in 90 ml of water. Yes, that means it gives a total of 100 ml solution, right? Yes, so what you can understand, 10% ethanol solution in water means, yes, 10 ml of ethanol is mixed in 90, that is dissolved in 90 ml of water, or else you can also say 10 ml of ethanol present in 100 ml of solution. Yes, I hope volume percentage is clear. Now moving on to the next concentration term, that is mass by volume percentage. We studied mass by mass percentage, volume by volume percentage. Now we are studying mass by volume percentage. So it is represented by W by V. Clear? Now mass by volume percentage of a solution is defined as mass of solute dissolved in 100 ml of solution. So how you can calculate it? Mass by volume percentage is equal to mass of the solute. In the numerator it will be mass, right? Mass of the solute divided by volume of the solution. Yes, on the numerator it is mass, denominator it is volume, right? Mass by volume percentage it is. So mass of solute by volume of the solution multiplied by 100. Clear? Right. So where is this actually used? This is useful when the solute is solid and the solution is liquid, right? If the solvent is in liquid state, yes, and the solute is in solid state, usually it will be easy to represent it in mass by volume percentage, right? If the solute is solid, that means it can be represented in terms of mass, right? And if the solvent is liquid, it is represented in the terms of volume. Clear? Right. And this unit is commonly used in medicine and pharmacy. Yes, in medicine and pharmaceutical industries, this is used, right? Now, let's do a numerical based on what we have studied till now. The mass by volume percentage of sugar solution is 10%. Find the mass by mass percentage. Yes, if the density of the solution is 1.25 gram per mole. Yes. What is given here? Mass by volume percentage is given and you have to calculate mass by mass percentage. Yes, so how do you calculate mass by volume percentage? Yes, mass by volume percentage is equal to mass of the solute by volume of the solution multiplied by 100, right? So, from that we know that it is given that it is 10%. Yes, that means, yes, 10 gram of solute. Yes, 10 gram of solute is present in 100 ml of solution. That is the meaning of mass by volume percentage, right? 10 gram of solute is present in 100 ml of solution. That is 10% mass by volume percentage, right? So, from this, what we can obtain? Yes, mass of solute is given, right? And the volume of solution is given. Right, but to calculate mass by mass percentage, what do we require? Mass of the solute, yes, that is already here, that is 10 gram, and mass of solution we require, right? The total mass of the solution is required. Yes, we have the total volume of the solution, but we do not have the total mass of the solution. But what is given? Density of the solution is given, right? So, density, what it is given as 1.25 gram per ml. It is given as 1.25. So, we know that density is equal to mass by volume, right? Density equals mass by volume. Yes, what do we have to calculate? The mass of the solution, right? So mass will be equal to density into volume, right? Mass will be equal to density into volume. Yes. So what is the density? 1.25 multiplied by what is the volume of solution? It is 100 ml. So 1.25 multiplied by 100 will give 125 grams. That will be the mass of solution, right? Mass of solute we already know, that is 10 gram, right? And mass of solution now we calculated, it is 125 gram, right? Yes, how do you calculate mass percentage? It is mass of solute by mass of solution multiplied by 100, right? So if you do the calculation, you get it as 8%. Right? So that is mass by mass percentage of the sugar solution. So I hope you understood from how the mass by volume percentage we will be able to calculate the mass by mass percentage. Clear? Now moving on to the next concentration term, that is parts per million. Right? Parts per million. So it is defined as the number of parts of solute dissolved in 1 million parts of the solution. Right? Till here we were discussing about 100 ml solution and 100 gram of solution. Right? So now we are going into million parts of the solution. Right? And we use this concentration term only if the amount of solute present is in trace quantities. Yes. So how do you calculate parts per million? It is equal to the number of parts of the solute by total number of parts for all components in the solution multiplied by 10 to the power 6. It is present, the number of parts of the solute present in billion of a solution, right? It is the number of parts of solute present in 1 million parts of solution, right? So it will be into 10 to the power 6, not 100. You have to be very careful with that. Yes, it is 10 to the power 6. Yes, and parts per million are also expressed in mass by mass percentage, volume by volume percentage and mass by volume percentage. Yes, so how you can represent it? Yes, parts per million will be equal to mass of solute by total mass of the solution multiplied by 10 raised to 6. In terms of mass percentage you can write, or else you can write it as, yes, volume of solute by volume of total solution multiplied by 10 to the power 6. Also you can write it in terms of mass by volume percentage, that is mass of solute by total volume of the solution multiplied by 10 raised to 6. So what you can understand, it can be expressed in all these three forms. Yes, but it is the number of parts of solute present in 1 million parts of the solution. Yes, so that means when the solute is present in very trace quantities, then only you use this parts per million concentration term. So I hope you are clear with the 4 concentration terms that we discussed today. So in the next session, we will be discussing mole fraction, yes, molarity, right? And then we will be moving on to the next topic, that is solubility. Right? So I hope the topics that we have discussed in this session is clear for you. So that's all for today. Thank you.